Have you ever wondered how a simple-looking rubber circle can control a 2-ton machine at over 200 kilometers per hour? Today, we're stepping inside a tire factory where heat, pressure, and chemistry come together to build one of the most important parts of your vehicle. This is how extreme performance tires are made, from raw rubber to high-speed perfection. Welcome to the world of tire manufacturing, a process that looks simple on the outside, but behind the scenes is filled with precision engineering, science, and surprising complexity. In the next few minutes, you'll discover what makes tire rubber so strong, how thousands of layers come together, why extreme performance tires cost more, and how factories test them to the limit. Let's begin at the very first step, the raw materials. Every tire begins with a mix of natural rubber, synthetic rubber, carbon black, and chemical additives. Natural rubber comes from tire trees, thick, sticky latex sheets. Synthetic rubber is made from petroleum and is engineered for durability. Factories receive these materials in large bales. Workers inspect them for impurities because even a tiny flaw can lead to failure at high speeds. The materials are weighed, sorted, and prepared for the most important part of the process. The heart of the factory is the Banbury mixer, a giant machine that blends rubber with chemicals at extremely high heat and pressure. Inside the mixer, rubber is softened. Carbon black is added to strengthen it. Silica improves road grip. Sulfur prepares it for vulcanization. Antioxidants protect it from aging. The mix comes out as a thick, hot slab of black rubber. It's then rolled into long sheets using heavy rollers. For extreme performance tires, the rubber compound is engineered with much tighter tolerances, offering higher grip and better heat resistance. Now, the rubber sheets go into extruders. An extruder is like a giant pasta machine that shapes rubber into different components. Treads, the outer part that touches the road, sidewalls, flexible layers that absorb impact, and inner liners, airtight layers that hold air. Each piece has a specific design. For example, high-performance treads use asymmetric patterns to grip the road during sharp turns and high speeds. The components are then cut to precise lengths, ready for assembly. This is where the tire finally starts to take shape. Inside the plant, a machine called the tire building drum assembles all the layers. First, the inner liner, then polyester casing plies, steel belts for reinforcement, nylon layers for strength at high speed, and finally, the outer tread. A typical performance tire can have more than 20 layers hidden inside it. Each layer is placed with exact alignment. If something shifts by even a few millimeters, the tire could fail at high speeds. Once all components are placed, the drum inflates slightly and forms the tire into a round shape. But it's still called a green tire because it's soft and unfinished. The green tire is moved into a giant machine called a curing press. Here's where the magic happens. The tire is pressed into a mold at high heat and high pressure. The heat activates sulfur in the rubber to create chemical bonds. This process is called vulcanization. This step gives the tire its final shape, its strength, its tread pattern, and its ability to handle high temperatures. Once cured, the tire pops out looking like a finished product. But the factory is not done yet, not even close. High-performance tires must pass extremely strict tests. X-ray inspection. The tire is scanned to ensure steel belts are aligned perfectly. Uniformity tests. Machines rotate the tire at high speeds to measure vibration and balance. Air inflation tests. Tires are pressurized far beyond normal levels to check for leaks and weak spots. random destructive tests. Some tires are sliced open to inspect internal layers. Only after passing all these checkpoints does a tire earn approval to go out into the world. Workers visually inspect every inch of the tire, the sidewalls, tread edges, bead area. A single defect means the tire is rejected. Approved tires are then washed, labeled, and stacked for shipping. They're sent to automakers, dealerships, or performance shops where they will eventually be mounted onto vehicles. A tire's journey from raw rubber to a high-performance machine is complete, but its real purpose begins on the road. Tires might look simple, but behind every one is a world of chemistry, engineering, and craftsmanship. They carry your safety, your speed, your control, and now you know the incredible process that builds them. If you enjoyed this deep dive inside the rubber plant, don't forget to hit like, subscribe, and tell me which factory we should explore next. Maybe luxury shoes, airplane engines, or supercar assembly. Your suggestion might be our next episode.